Yeah, take this thing. Work done in pulling the chain. Work done in pulling the chain. Right. So means what they're saying here in this case. So there is a table. Now, so they're saying that a chain which is placed like this. Hmm. In friction, we have seen this thing now. Right. The chain is like this now. Here, chain is which is hanging. Some part of the chain is hanging. So total mass of the chain is m, length of the chain is capital L. They given that 1 by nth of the chain is hanging. And then they ask him to find what, tell me now here, the work done by the pulling force to bring the hanging part of the chain on the table. That means now here some part is simply hanging over this thing here. Now we are applying some force we applied. So then, so that here this complete chain has to be come to the on the table. And here this is here we are applying my force we applied. And here there is no gravitational force. Here the work is done by applied force, external force. That means in this case, what is the relation between the work done and the change in potential energy relation? What the relation we have seen work done, not force. Force is derivative. The work done relation we have seen as work done by the non-conservative force we have remembered. So that is for conservative force. In case of non-conservative force, we told na work done by the non-conservative force, which is equal to simply change in potential energy. Okay, the work is done by who? Yes, external force. Gravity, what the gravity will do? Will make the body to fall down. But here, what I need to do here? Change has to move up now, not down. Isn't it? Work is done by the external agent. That's why in this case there is no minus. It is a non-conservative force. So non-conservative force work done is what, tell me now, relation? So here simply delta U. There is no minus, keep in mind. Now fine. So here look at now here. Let's understand this thing. These model problems are very important. Now so total mass is M. Some part is hanging. How much part is hanging? So that means L by N is hanging. How much hanging? L by N. So this means this length I can write as L by N a total length. Total mass is how much? M. So this means can you tell you mass of the hanging part? So that is M by N I can say. Hanging mass. Okay. Now look at now here. This is the hanging mass now here. Now you tell me now here. I am taking. So this table surface is there now. The table surface I am taking as a reference line. Table surface as a reference line. Now you tell me now. So we are finding initially this is the situation. Now that is a potential energy. How much you tell me now here? So potential energy, initial potential energy. Yes, what the initial potential energy means? What now? This is hanging now. This has some potential energy part now here. This mass. Okay, you see this thing here. This part lies on the reference line. Potential energy 0. But this part is hanging or not? Then this mass here, this mass is, if I call this as M2, what we can say, tell me now, M2G into, that means what, tell me now here? We have taken this has a reference line, we have taken fine. Now if you have taken now at this location 0, but here at this location L by N. This is what tell me now at this location how much? 0. Here it is what tell me? L by N. Then what has to be taken? Center of mass we should be taken. Where the center of mass will lie? Here. So this means here is the center of mass. That means how much now? L by 2N. So that's why M2G into what tell me now? L by 2N. And here this is the downwards na. So that's why minus. Why negative? It is below my reference line. That's why negative. This is the initial position na. Now what is M2 means? What tell me? That is how much the mass is a. Yes, M by N G L by 2N na. So that is how much the U1 value tell me now? Minus mgl by 2n square. This is the initial potential energy. Right. Now finally what I need to do? Yes, initially. So here this is the situation we have. Finally what I need to do here? Completely I need to bring here. When it is completely on the table, this one, the complete chain lies on the reference line only. How much the potential energy? 0. Then final potential energy is how much? 0. Right. Now what we can say now, work done is equal to what? Tell me now. Change in potential energy. That is U2 minus U1. Final potential energy minus initial potential energy. So here U2. Why U2 0? Because the entire complete chain will come on the table now. That means table is a reference line we have taken. So which will be equal to U2 minus U1, which is equal to what? Tell me now. U2 value 0 minus or minus plus. That is mgl by 2n square. So this is the work done. Final work done is how much now? mgl by 2n square. Yeah. So remember this thing, this is one formula. Work done case, we have to use this formula.